Remember in the opening program how we showed you this concert and asked you to find resistance in action? Well, here it is. The violin bow has a high coefficient of friction, so it sticks to the violin strings and makes them vibrate. The tape recorder uses friction between the rollers to drive the tape. The sliders on the mixing board use electrical resistance to control the volume of the speakers for the microphones. When people cheer, the sounds we hear are because of the fluid resistance from their vocal cords on the air in their lungs. And of course, who could clap without the resistive force of one hand against the other? Resistance. About the only place you can move something and not encounter resistance is here, where there's no air and objects can move freely. Every other kind of motion, whether it be an object, a fluid, electric charge, or heat, involves resistance of some kind. We can't get away from it. Resistance affects the rate at which something moves, so it has to be considered if we want to move something. The nice thing about the formula for finding resistance, force divided by rate, is that it works across the four energy systems. All you need to find is the force that's responsible for the motion and the rate that's being affected by the resistance. In mechanical systems, drag is the force and speed is the rate. In fluid systems, pressure drop acts like force and resistance cuts down on the flow rate. Electrical systems, voltage is the force and the current is the rate. And thermal resistance acts against temperature difference and slows down the rate of heat flow. In every case, resistance opposes a force and affects a rate. Look at these forces. Do they look familiar? You've seen them in our first unit on force, where we looked at these influences and how they cause things to move. Motion leads to rate. And in our rate unit, we saw how the rates measure that motion. Now to find resistance, we're dividing force by the rate. Resistance and its opposite, conductivity, are very important to measure in technological systems. And for technicians like Lane Ito, they're very well aware of its role.
Oh. If we didn't know about drag and resistance, it just wouldn't work.
The reason it wouldn't work is because of control. Introducing just the right amount of resistance at the right time allows us to control rates. If resistance was eliminated altogether, a force could cause something to move faster and faster. Or cause something to be out of control altogether. This program was produced at the facilities of Telemation Productions and is part of Principles of Technology, a project of state and provincial vocational and technical education agencies in association with the Agency for Instructional Technology and the Center for Occupational Research and Development. Together, serving education.